Hello everyone and welcome to IT-KnowledgeBase. In this video, I am going to demonstrate to you how to set up an Acme package to issue, renew and auto-renew a 90-day free Let's Encrypt signed SSL certificate and to secure your pfSense firewall with SSL in the up-to-date version of pfSense 2.7.0 release at the time of this recording. pfSense firewall is the more than a firewall and router. We are going to generate a signed or public certificate aiming to secure our pfSense WebGUI or web configurator, web servers running behind this firewall, OpenVPNs running on pfSense, load balancing web servers, HAProxy and ReverseProxy, etc. Secondly, after the certificate generation process, you could export this signed certificate from your pfSense firewall and import it into your server to secure your services. In this training, I'll take you through innumerable hands-on step-by-step installing, configuring, issuing, renewing, and the best part is auto-renewing SSL certificates. So you can utterly secure your pfSense firewall and other services as obvious. In this video, I will cover how to generate an account key, create a certificate, issue a certificate, configure general settings, use certificates, certificate auto-renewal, rate limits, security limitations, different types of domain validation processes, and obtaining a certificate. You have to pay attention and watch the entire video to get hands-on exercise with full confidence. After this video, you will autonomously manage your Acme package and generate your Let's Encrypt SSL certificate. Okay, now let's jump over to our next slide. Let's explore my distinctive network scenario in my virtualized lab situation, where I typically run heterogeneous servers in the LAN, DMZ, and multi-homed WAN connections with failover. Later on in our upcoming pfSense videos, we will definitely cover extensive configuring of some NAT rules or port forwarding, so our server will be able to be accessible or go live over the internet. For a successful demonstration, we also have a remote site a user sitting outside of my corporate network, aiming to access core server services, for example, web servers running behind an HAProxy, also using ReverseProxy in my other pfSense. And OpenVPN with Tranquility is configured. This is a typical internet flowing procedure. A remote user or workforce keen to access our corporate web or online application through the FQDN. The request always first goes to their respective DNS servers to resolve the FQDN into the right IP address. As soon as the DNS responds to the query, the client request will send to the right target server. In this video, we are going to install, configure and manage the Acme package Let's Encrypt certificate to secure our pfSense firewall and the web server. Later on, we will access both the pfSense firewall and web servers from the external side. If you would like to know how I installed and designed my network with pfSense firewall from scratch with multiple NICs, one for LAN, a second for DMZ, and the rest of the network for the internet, which is called a multi-home network, then watch my video created earlier and also provided the URL in the description. Our lab environment is fairly strict. We are using the most up-to-date pfSense version 2.7.0 release and Acme Package 0.7.4 for automated certificate management environment and for automated use of Let's Encrypt certificates. Acme overview. Package Acme provides an implementation of the automatic certificate management environment specs most famously used by Let's Encrypt. Most common scenarios will want to use an AutoCert subdirectory instead, which provides automatic access to certificates from Let's Encrypt and any other Acme-based CA. Let's Encrypt is an open, free and completely automated certificate authority from the non-profit Internet Security Research Group, ISRG. The goal of Let's Encrypt is to encrypt the web by removing the cost barrier and some of the technical barriers that discourage server administrators and organizations from obtaining certificates for use on internet servers, primarily web servers. Most web browsers trust certificates from Let's Encrypt, and these certificates can be used for web servers, HTTPS, SMTP servers, IMAP and POP3 servers, HAProxy, OpenVPN, ReverseProxy and other similar roles which utilizes the same type of certificates. The Acme package for pfSense software interfaces with Let's Encrypt to handle the certificate generation, validation and renewal processes. Certificates from Let's Encrypt are domain validated, and this validation ensures that the system requesting the certificate has authority over the domain in question. This validation can be performed in a number of ways, such as by proving ownership of the domain's DNS records or hosting a file on a web server for the domain. And the recommended way to validate your domain ownership is with DNS records. Either add manual DNS-TXT record or add an API to automatically create DNS-TXT record for domain validation. By using a certificate from letsencrypt for a web server, including a firewall running pfSense software, the browser will trust the certificate and show a green checkmark, padlock, or similar indication. The connection will be encrypted without the need for a client to manually trust an invalid or self-signed certificate. Let's Encrypt certificates are valid for a period of 90 days, so they must be renewed periodically and automatically. The Acme package automates this renewal by using a cron job to check once per day to see if a certificate needs to be renewed. Rate limits. Let's Encrypt enforces rate limitation when using the production validation system, such as 5 validation failures per account per host name per hour. Each certificate may have at most 100 SANs or subject alternative names entries. Only 50 certificates may be created per domain per week, which is plenty of domains, it's my hunch. There is also a testing validation system that exists for developers who are programming clients or administrators testing their settings. The test system has higher limitation which aid testing and development, but the test system does not produce certificates that are trusted publicly. We will choose a production so that our service will be live on the internet. Security limitations. When validating using a method such as webroot or standalone, the service must be available on the internet on its standard port 80 for HTTP or 443 for TLS-ALPN. This is a security limitation to prevent a user from running an alternate web server on a high-numbered port and obtaining a certificate for a server they do not normally control. Validation method. Acme providers can validate by checking the content of a TXT record in DNS Manager or by fetching a file in a known location from a web server. The Acme package supports validating directly with the standalone method or webroot, but those options are less secure than DNS-based options. The Acme package also supports numerous methods to update various DNS providers. Wildcard certificates can only be obtained through DNS-based methods. Here is a quick tip for you. DNS-based update methods are the best practices as they do not require external inbound access. They can be used for internal systems that do not allow or cannot receive internet traffic. Validation method, DNS manual. The manual DNS method can be utilized when a firewall cannot receive inbound traffic and it does not have access to any automatic DNS-based method. The manual in the name indicates that the process must be performed by hand, both initially and when it is time to renew the certificate. The firewall obtains the authorization value and then the TXT record must be manually created or updated with this value. To use this method, add an entry to the domain SAN list. Mode set to enabled. Enter the domain name, for example, pfs.itkbconsultant.com. Set method to DNS manual. Click Save. Click Issue. Locate the record info in the output. Add or update the TXT record in the domain's DNS server for acmechallenge.domain.com with the TXT value from the output. Wait approximately 2 minutes or longer for DNS to propagate and click Renew, and that's all we have to do to generate a certificate with DNS manual. Validation method domain APIs. For certain accounts with domain APIs, access may be obtained that allows remote manipulation of DNS records. This can be used with the Acme package to validate certificates for domain with hosted at Namecheap, GoDaddy, etc. using their basic DNS servers. Please note the warning here. The domain and DNS APIs requires that the client read all records and then write them all back when making any changes. This is potentially dangerous. Take a backup of all DNS records on the domain before attempting to use the API. Validation method PFTP webroot. The FTP webroot method is useful when the firewall is performing a network address translator, port forward or one-to-one, or reverse proxy duty for handling traffic for the domain. The firewall can use SFTP or FTPS to store the domain validation files on a web server behind the firewall so it does not have to host the files themselves. This method has the following options. Server, the server where the package will send the challenge response files, for example SFTP and the server IP address. Please note, this method supports SFTP and FTPS servers, username and password, credential for the SFTP and FTP's account, folder, full path to the target directory. This is the most common challenge type today. Let's Encrypt gives a token to your Acme client, and your Acme client puts a file on your web servers at this location. That file contains the token plus a thumbprint of your account key. Please note the warning here. Make sure the specified user has written permission to this directory. Validation method web root local folder. This method works similarly to the FTP web root, but with the files hosted on the firewall itself. This method cannot be utilized by the GUI web server, as that would mean exposing the GUI to the internet, which is a major security issue. This method can, however, be used in conjunction with the HAProxy package to host the files on the firewall itself in some circumstances. Validation method standalone HTTP/TLS-ALPN. The standalone method for HTTP and TLS-ALPN runs a small web server natively that is actively only while the validation process is running. This method is more secure as it encrypts communication with the Acme provider, but there is a caveat here. If the firewall is using port 80 HTTP or 443 TLS-ALPN for another service, such as the firewall GUI or its redirect, then this method may not be viable. If the service on the port is public, then it cannot be used. If the service is private, then it may be possible to relocate the existing service or bind the update method to an alternate port. Then port forward on the WAN interface. A firewall rule must allow traffic to the target port all the time. It cannot be automatically enabled and disabled in the current package. The standalone binding should only be changed if the port is forwarded via NAT to a different port. For example, port 80 forwarded to 8080. Please note the warning here. These methods are not best practices as they expose a service on the firewall to the internet. Only use this method if no other method is available, and the service must be accessible using port 80, HTTP, or 443 TLS-ALPN. Validation method standalone HTTP. Standalone HTTP server has the following option. The package will bind listening for HTTP request with a standalone server. Port 80 must be forwarded to this port on the default gateway WAN. If port 80 is used by the standalone service, the GUI redirect must be disabled under the System, Advanced, and place a check on the Disable Web Configurator Redirect rule option. If the redirect is active when standalone mode attempts to use the port, it will print an error message stating that SOCAT is unable to bind to the port. Validation method Wildcard certificates. Let's Encrypt also supports wildcard certificates, for example, *example.com with their Acme version 2 infrastructure. A wildcard certificate will work for any host name inside a given domain, which helps with handling certificates for multiple domains. A wildcard only helps for one level of subdomain. For example, *example.com will work for host.example.com, but will not work for host.sub.example.com. If hosts are structured in this way, a wildcard certificate is required to each subzone, for example, *sub.example.com. Wildcard validation requires a DNS-based method and works similarly to validating a regular domain. For example, to get a certificate for *example.com, the package updates a txt record in DNS the same as it would for example.com, which means the DNS record and potentially key name would be like this for _acme-challenge.example.com. To obtain a wildcard certificate, follow the same procedures as other DNS validation methods with the following differences. The key account must be registered with an Acme version 2 server staging for testing or production, but I would prefer to choose a production server here. The domain SAN list should contain entries for the base domain, for example, example.com, and the wildcard version of the same domain, for example, asterisk.example.com, the setting will be the same for both entries. For DNS, NS update or RFC2136, set the key name to the base domain, example.com for both entries. Validation process. When creating a certificate, one or more fully qualified domain name or FQDNs are listed on the certificate in the SAN list. Let's Encrypt will query each of these domain names in DNS in different ways, depending on the validation method. When a validation method starts, the client obtains an authorization value from the server auths. For DNS-based method, Let's Encrypt checks for a TXT record in the form of _acme-challenge.domain.com. At this location on the root folder of your domain, underneath the web root directory, this file contains the authorization value. This proves that the person or system requesting the certificate controls the web server for the domain name. Account key settings. You must have to set up an account key settings before configuring your certificate. An Acme account key has the following settings: name, a short name for the key; description, a longer string describing the key, and here you should reference the relevant purpose; Acme server, to which this key will be registered by the package. Currently supported options are Let's Encrypt staging Acme version 2. Use this server when testing the certificate validation process. Does not produce publicly trusted certificates. Let's Encrypt production Acme version 2. Use this server for trusted production certificates. You can safely use this for production to get your server SSL protected. Bypass production Acme version 2, Zero SSL, SSL.com, and Google. These all are alternative services for Acme certificates. Email address. Let's Encrypt will use to send certificate expiration notice and if certificates are not renewed in a timely manner. Account key. The RSA private key for this entry to create a new key. Certificate settings. After the account key settings, we have to precisely deliver all the certificate settings entries which are compulsory for issuing the certificates. Name, a short name for the certificate; description, a longer string describing the certificate; status, whether or not this entry is active. Active, this entry will be proceed manually and by the cron job. Disabled, this entry will be ignored or disabled. Acme account, the account key which we created earlier in the account key settings, Acme will use when requesting the certificate. We have to create account key settings first because we have to provide it here in the certificate settings. Private key, the key length of the private key for the certificate may be either RSA or ECDSA in several predefined sizes. Select custom to manually enter a private key generated elsewhere. 2048-bit RSA is an acceptable default choice, but larger keys are more secure. OCSP must staple. When set, Acme will configure the certificate request for OCSP stapling, but here is a warning: do not enable this option unless all consumers of the certificate support OCSP stapling. Domain SAN list, a list of all domain names which will be included in this certificate as subject alternative name entries. Please note, a certificate can contain up to 100 SAN entries and they can use the same or different update methods. Each SAN must be individually validated by Let's Encrypt before a certificate will be issued. Mode, whether or not this SAN is active in the certificate. Domain name, the domain name for a SAN entry in this certificate, for the example given below, could be your FQDN or wildcard domain, for example. Method, the method used by Acme to validate ownership of this domain. DNS slip, the amount of time the Acme validation process will wait after making DNS changes before attempting to validate. Some DNS services take a few minutes to propagate entries after making backend changes. The default settings are typically sufficient, but slower provider may require a longer sleep time. Action list, command to run after the package renews a certificate. Last renewal, the last time this certificate was renewed. Certificate renewal after, when the package will attempt renewal for the certificate. The default is 60 days or 2 months. Certificates are valid for a maximum of 90 days, and before their expiration, you could set it to renew automatically. There are various ways to generate a certificate for secure communication. Option number 1, To use an externally signed SSL certificate and key, import them using the certificate manager, then select the certificate here. Option number 2. The Acme package in pfSense can utilize the free Let's Encrypt certificate service to automatically obtain and update a signed certificate for the GUI or for other purposes on the firewall. Option number 3. Another alternate technique is to generate a self-signed certificate authority and then generate a GUI certificate from the CA. Export the CA or certificate authority from the firewall and then import that CA into the client browsers manually. Using this method, all certificates signed by that CA will be trusted by browsers, and this is specifics vary by client platform. But in this demo, we will go with option number 2 to install, configure, issue, and renew the certificates from the Acme package. Now let's jump onto our demo session and dive into the immense hands-on learning and configuration for successful testing. In this demo, we will cover installing Acme package, configuring account keys, configure certificates, issuing and renewing certificates, general settings, assigning SSL certificates for pfSense WebGUI or web configurator, and at the end, some notes. Installing Acme package. So here are the precise steps on the process to install the Acme package first, and then configure it properly to generate and enable signed Let's Encrypt SSL certificates on your pfSense web interface. In this demonstration, we are going to generate a certificate for our pfSense firewall and for our internal web servers. Later on in my upcoming videos, I will use this same Acme package to generate more certificates for other servers running behind the HAProxy and ReverseProxy. I'm already jumped into my client machine running Linux Mint. Open the web browser and log into the pfSense firewall. As you can see, pfSense is not secured. A self-signed certificate is there by default, but its impractical SSL uses the default port 80 HTTP protocol. Later on, we will secure our pfSense firewall for sure with the SSL certificate and essentially customize the default login port from port 80 HTTP to something different to free up port 80 HTTP and 443 HTTPS and assign it these default ports to our internal web servers freely. Navigate to System, Package Manager, click on Available Packages, search Acme Package, and now you should be able to find it. Click the Install button and allow it to complete. Once installed, you should find Acme certificate under the Services menu. Now the time has come to configure all the options and issue our first certificate. We have to generate an account key first. Before a certificate can be created by the firewall must first obtain an account key. This key is typically unique for each server but can be shared. Create an account key for the production system and then issue the certificate again using that key. To create and register an account key, click Add. Fill in all the information which describes your certificate options well. Provide the name. I will use pfs.itkbconsultant.com. In this example, I am using the exact certificate name. I am generating this SSL certificate for my production pfSense firewall WebGUI. Enter the description, which should portray the exact purpose of the certificate. And in the Acme server, select the Let's Encrypt Production Acme version 2. If you want this to be live, enter the email address to register this key and send automated certificate expiration notices. Now click on the Create New Account key. Click Register Acme Account key. Now click on Save. The next step is to create a certificate entry. Click Add. Fill in all the information which describes your certificate options well. Provide the name. I am pasting my FQDN name here, pfs.itkbconsultant.com. In this example, we are generating our SSL certificate for pfSense Firewall WebGUI. Status: should be set to active. Select the right Acme account which was created earlier in the account key settings. Default private key 2048-bit RSA is fine. OCSP must be stable, leave unchecked. Preferred change, leave the default. We are not managing trusted chains here. Now add one or more domain SAN list entries which appropriate validation settings. The mode should be enabled. For a domain name, enter your wildcard or a fully qualified domain name. For example, I am using a single domain name pfs.itkbconsultant.com. Select method and choose DNS manual. To enter the manual DNS TXT record, add one or more action list entries if required, but in my case, I will leave it as default. Last renewal, the last date and time this certificate was renewed. Certificate renewal, after when the package will attempt a renewal for the certificate. The default is 60 days or 2 months. Certificates are valid for a maximum of 90 days. And before their expiration, you could set it to renew it automatically. I will choose 75 days. To renew it automatically days earlier before its get expired. Now click on Save. Now it's time to generate our first Let's Encrypt SSL certificate. Click on Issue. The client obtains an authorization value from the server auths. Please note this TXT record and values. You have to create a DNS TXT record in your domain manager and have to wait until it propagates successfully. Wait for a few minutes and click on the Renew. I have already paused my video for 2 minutes for updating the DNS TXT record in my domain manager. Now click on Renew button. Now you should see the successful certificate generation status here. And now your first Let's Encrypt certificate is generated and ready for use. Its last step is to enable at least the cron entry to ensure that the Acme package will automatically renew certificates before they expire. See General Settings for detailed descriptions of the options. These settings control the general behavior of the Acme package and are not specific to any single certificate or key. Cron entry, a checkbox that enables the Acme renewal cron job. When set, the Acme package will check all certificates each night, and if any are up for renewal, it will attempt to renew them. Write certificates. When set, the Acme package will write the certificate file out in the Acme home folder. From there, other scripts or processes which do not support GUI integration can pick up the certificate. I will leave uncheck here. Make sure you put a check mark on cron entry and click on Save. To verify whether the Let's Encrypt certificate authority and certificates are generated in the pfSense firewall, go to the System, Certificates, and check the certificate authority. Yes, it's newly generated here. Click on Certificate tab and check our newly generated signed Let's Encrypt certificate. Now we have seen how to generate a single domain or multiple domain SSL certificate, and to generate a wildcard SSL certificate, there are some noticeable bit differences. To install a wildcard certificate, we have to generate an account key first. Before a certificate can be created by the firewall must obtain an account key. This key is typically unique for each server, but can be shared. Create an account key for the production system and then issue the certificate again using that key. Navigate to Services, Acme Certificates, click on Account Keys. To create and register an account key, click Add. Fill in all the information which describes your certificate options well. Provide the name. This time I will use @itkbconsultant.com. In this example, I am using the precise certificate name, generating this SSL certificate for my production web servers, and will be assigned this certificate when configuring HAProxy and ReverseProxy later on other video. Enter the description, which should portray the precise purpose of the certificate. I would choose to describe wildcard _cert_ web servers. And in the Acme server, select the Let's Encrypt production Acme version 2 server if you want this to be live. Enter the email address to register this key and send automated certificate expiration notices. After you have filled everything out, click Create New Account Key and then click on Register Acme Account Key. Once that been successfully completed, you'll get an account key in the account key field and click on Save. Now that we have an account key, we can start creating certificates. Go to Certificates tab and click on Add. Fill in all the information which describes your certificate options well. Provide the name. I am pasting my Wildcard domain name here. Description: Wildcard Certificates Web Server. Status should be set to active. Select the right Acme account which was created earlier. This should be the Acme version 2 account key. Default private key 2048-bit RSA is fine. OCSP must stable, leave unchecked. Preferred chain, leave the default. We are not managing trusted chains here. Under the domains and list, you'll want to add 2 entries. For each domain you want a wildcard for. One plain and one with the wildcard. For example, if I wanted a wildcard domain for itkbconsultant.com, then I'd have to add both itkbconsultant.com and *itkbconsultant.com. The mode should be enabled and select the method Choose DNS manual. To enter the manual DNS.txt record. Last renewal, the last date and time this certificate was renewed. Certificate renewal, after when the package will attempt a renewal for the certificate. The default is 60 days or 2 months. Certificates are valid for a maximum of 90 days and before their expiration, you could set it to renew automatically. I will choose 75 days to renew it automatically days earlier before it gets expired. Click Save. Alright, there is one mistake that I have done and needs to be rectified. Special characters is not allowed in the name, so we have to rename it. Now click on Save. Set the general settings. If you want to do something with your certificates after they have been issued or renewed, writing them to a location on the pfSense server is convenient. To do this, on the General tab, check the Write Certificates options and click on Save. Now we are set to get some certificates. Under the Certificate tab, you should see your newly created certificate. Click the Issue and Renew button. This will start the process of requesting a certificate and validating that you have ownership of the domain. Once the process completes, you will be prompted with a big screen wall of text. Be sure to read it carefully. Even though it's green and the top may say success, there could be errors listed that you will want to resolve. Now that you have got your certificate, here we have to note the DNS.txt record, which we should have to add in our public DNS manager. Let me add this DNS.txt record and then I'll get back to you in a few seconds. I have added the required DNS.txt record and click on the Renew button to verify the DNS.txt record and generate our wildcard certificate. Now it's time to secure our pfSense firewall, and we have a successfully generated single and wildcard domain SSL certificates. The best practice is to always use HTTPS in your pfSense firewall as a secure channel for all types of communication, especially when you are accessing your pfSense firewall all the time. Here I am solely talking about the default pfSense firewall WebGUI, non-secure console to secure it with an SSL certificate and to turn off the insecurity. In humble words, we are going to configure our pfSense firewall into highly secure access WebGUI with SSL protected console to prevent from all types of local and external security risks. Modern browsers may complain about the certificate, but an exception can usually be stored, so it will only complain the first time. To disable or re-enable HTTPS for the pfSense WebGUI, navigate to System, Advanced, under the Admin Access tab, using the protocol option in the Web Configurator section. The options on this tab governs various firewall administration methods. including via the web interface, SSH, serial, and physical console. The very first one is protocol for connections between web browsers and the GUI. HTTP is plain unencrypted, insecure, and basic, but widely compatible, should not be used in most cases, and should never be exposed to insecure network. HTTPS SSL TLS, it's encrypted with secure HTTP, protects communications between the client browsers and the firewall GUI. Requires an SSL TLS certificate to function. Select this option. Please note, the best practice is to use HTTPS to exchange only encrypted traffic between the GUI and the clients. And then we have to provide here SSL TLS certificate to be used by the GUI in HTTPS SSL TLS mode. The firewall automatically generates a default self-signed certificate on the first boot. The self-signed certificate is not ideal, but it does still encrypted traffic and is better than communicating without encryption. The primary disadvantage of a self-signed certificate is the lack of assurance of the identity of the host, since the certificate is not signed by a certificate authority trusted by the browsers. Select the newly generated SSL certificate for this pfSense firewall, and we generated the certificate pfs.itkbconsultant.com earlier to use to access this pfSense firewall. TCP port, the port upon which the GUI listens for incoming connections from browsers. By default, the GUI uses port 443 HTTPS with a redirect from port 80 HTTP for the best compatibility and ease of initial configuration. To change the port, enter a new port number into the TCP port field. Here I am going to use 10,000 to free up port 443 to use later on for our web servers. By default, the pfSense firewall is using port 80 HTTP and port 443 TLS ALPN. So on the same IP, port forwarding to the web servers is not possible until we've changed these ports or assigned another IP address where these default port 80 for HTTP and port 443 for HTTPS is not reserved. So it's always a recommendation to change these default ports. But there is a security risk. Do not expose to GUI to untrusted networks such as the internet, even on non-default ports. Some administrators move the GUI to an alternate port for security by obscurity reasons. Such practices should not be considered as offering any security benefits. It is trivial for port scanner to locate the services on any given open port. Here is a quick tip. Moving the GUI to another port will free up the standard web ports for use with port forward or other services such as HAProxy and ReverseProxy on port 80 HTTP and port 443 HTTPS. Maximum processes, the number of web server worker processes used by the GUI when listening for client browsers connections, and the default value is 2. If multiple administrators viewing the GUI at the same time and pages take too long to load or are failing to load, then increase the maximum processes value. WebGUI redirect controls whether or not the firewall runs a redirect on port 80, so that if a browser attempts to access the firewall on port 80 HTTP, the firewall will accept the request and then redirect the browser to the TCP port 443. The redirect is enabled by default for ease of access and compatibility. Disabling the redirect allows another daemon to bind to port 80. It's a best practices to should not select this option. OCSP must staple. It's an online certificate status protocol. It's a certificate extension that was introduced to address the slow performance, unreliability, soft failures, and privacy issues associated with it. Basically, it controls whether or not the GUI web servers forcefully enables OCSP stapling. We will definitely cover all these options in great details in our upcoming pfSense best practices videos. Now scroll all the way down and click on Save. Now wait for a few seconds. It will populate the new settings and redirect to the same URL with HTTPS. Click on Advanced, click Accept the risk and continue. Now to test if all is set up correctly, you should be able to enter your domain and it should connect to your server with an SSL connection using a valid certificate. To be safe, open up the new tab and type the secure HTTP FQDN URL https://pfs.itkbconsultant.com:10,000, and now you are in. Verify the certificate. This is our newly generated certificate by Acme Package. Let's encrypt the certificate and shows a secure connection, green check mark, padlock or similar indication verified by Let's Encrypt. Log in with your credentials, and yes, we are now using our secure pfSense firewall WebGUI. And that's it, you are done. In this video, we have covered step by step installing the Acme package, and it's all the essentials. We have generated single and wildcard certificates, You can now use Let's Encrypt to secure the encryption between the users accessing the systems, websites, and applications running behind your pfSense hardware and virtual appliance over a secure network. If you have any issues or questions, you can reach out to me. I'd be happy to help you. Alright, that's all for the now. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Thank you.